In preparation for lab number 2 on circuits in EECS 1011, we're going to do a quick simulation of connecting up components on an electrical breadboard using a program called Fritzing. The nice thing about Fritzing is that it animates the individual connections on the columns of a breadboard really well. So we'll use that to demonstrate how to do this. Okay, so the first thing we're going to do is drag in a battery pack. Now, you'll notice these are AAA batteries in the battery pack. We're actually using AA's in our battery packs in EECS 1011. The next thing I will do is drag in one resistor, right there, and another resistor right there. Now I'm going to zoom in on this. Now you'll notice that as I move the resistor around, the possible connectors or possible connections that can happen are highlighted in blue, and as soon as I lay it down and let go, the columns in the breadboard that allow for electrical connections to the resistors come up in green. So I'll bring this resistor over as well, and I'll make them connected together. Move that over a little bit more, and again. So you'll see that these two resistors, this one and that one, are connected together through this column at column 40 of the breadboard. So what's highlighting in yellow right now, that's where they're connected together. I'm going to zoom out again. I am now going to bring in an LED. Here's the LED. I'm going to zoom in on it. The important thing to notice here with the LED is that it has a round base up to this side right here. At this side it has a flat edge to it. That flat edge corresponds to one of the wires that comes out of the LED. The other wire corresponds to the rounded edge, and that's the difference between the anode and the cathode. The cathode is the side with the bar or with the flat side to it, and the anode is the opposite side. It's this side over here with the rounded edge as well. Okay, so I'm going to zoom out. I'm going to bring this LED into the circuit board right here. I'm going to connect a wire from this resistor to the anode of the LED. I'm going to then connect a wire from the cathode of the LED to the negative end of the battery pack, like that. And then over here I'm going to take a connection from the positive end of the battery pack, the red one, and connect it up to the other end of the resistor. So what we have here is the red wire of the battery pack connected up with column number 40, 41, 42, 43, 44. So column 44 connected to this resistor. This resistor is connected to the next resistor in column 40. This resistor is connected up to the LED via a wire in column 36. And you can see that because of the wire that joins across the valley in the middle of the breadboard, the column in 36 is connected up to this column over here. And so we know that this resistor and that LED are connected up using that wire. And then finally, this last column right here, which connects the LED to the wire, is also connected to the black terminal on the battery pack. One of the interesting things about Fritzing is that as you build the model on the breadboard, it actually populates the schematic diagram as well. So if you have some confusion as to what certain schematic symbols mean and how they connect together, you can build your whole circuit on your virtual breadboard or on your real breadboard, and then take a look at the schematic diagram in Fritzing and manipulate it a little bit. So let's move the battery over here, like that. Let's move the LED over there. A resistor there. A resistor there. Let's complete the circuit diagram by double-clicking on the dashed lines. And there we have a schematic diagram that shows a battery, a resistor, another resistor, and an LED. And that's what your circuit diagram looks like on the breadboard.